Programming is cool, they said. It'll be fun, they said. Look, I don't know who they is in this scenario, but they forgot to mention that you can spend 2 days trying to figure out why your code isn't working, wondering if your brain is malfunctioning, and just before you go completely insane, you realize that you didn't read the documentation properly, and all it takes to fix it is changing one word. Ah yes, the joys of programming. So yeah, making multiplayer games kinda sucks. Over the last few weeks, I've been working on re-implementing client prediction into my game, and player movement is once again nice and responsive. But why was the movement unresponsive in the first place, and what the heck is client prediction? Well, let me introduce you to the arch enemy of all game developers that are working on multiplayer games: latency. You're able to watch this video right now because YouTube's servers are sending the video's data to your web browser. However, this doesn't happen instantly, as it takes time for that data to physically travel from YouTube to your computer. That travel time doesn't really make a difference when you're watching a video or stealing someone's code, but if you're building a fast-paced multiplayer game where reaction speed is critical, latency will literally make your job go from easy to pure pain and suffering. Imagine light traveled 299,792,458 times slower than it actually does, or at 1 meter per second. Now imagine you're standing a meter away from someone. If that person took a step to the right, you would only see them start to move an entire second after they actually started moving. This is essentially the same problem that games face, because by the time your computer is told that another player moved, that information is already outdated. You can probably figure out for yourself why that would cause major problems in games like first-person shooters, where even a fraction of a second of delay in another player's position could cause you to be aiming at nothing. Seriously, when they were creating the internet, who decided that latency was a good feature to add? In this video though, I just want to talk about movement. A little delay wouldn't make movement unresponsive on your end, right? You could just have every player's computer calculate and update their own position, the same way single-player games do it. Players would still see each other in the past, but at least they would see themselves move immediately after pressing a key. Unfortunately, this is where the second half of the problem comes in: cheaters. You can't trust your players because a certain amount of them will happily exploit anything they can, and often this will ruin the experience for other players. To prevent things like speed or fly hacks, you need your game server to be the one calculating the movement for all players, as it's the only thing you can trust. Unless of course you're an incompetent programmer, in which case you can trust nothing. So since the server has to handle your movement for you, that means when you press the W key to move forward, you have to wait for your computer to send that instruction all the way to the server. Then the server does the calculation, updates your position, and you have to keep waiting until that update finally makes it back to your computer. All of that might happen in less than a tenth of a second, but when you're at the controls, even that seemingly tiny amount of delay can make the movement feel sluggish. This is where client prediction comes to save us. The idea here is to have the client, which is your computer, and the server both calculate your movement. While you're waiting for the server to receive your input, calculate the proper movement, and send back the result, your computer will also calculate the movement and update your position accordingly, which means that when you press a key, you will move immediately. Then when the server eventually sends back what it determined to be your new position, we have your client compare that correct position to what it had predicted for the same point in time. If they match, which should be the case most of the time for a non-cheating client, then all is well with the world. If they don't match, the position needs to be corrected, but because nothing is allowed to be simple when developing a multiplayer game, it's obviously not as easy as just overwriting your current position. Since your current position is predicted, and therefore essentially from the future, and the position from the server is technically in the past, the two can't just be compared, because when you're moving, they actually should be different. We're basically dealing with multiple time streams, meaning that time travel doesn't just happen in books and movies. Your computer is constantly doing it every time you play a fast-paced multiplayer game. I won't go into any more detail though, because this is the point where things get even more complicated and confusing, and I'd rather get back to the practical side of things. Remember how at the beginning of the video I said, player movement is once again nice and responsive? Well, I lied. Sort of. The movement is smooth and responsive on land, but this is what happens when you step on a boat. Why? Remember our good friend Latency? Yeah, me neither, because latency is the enemy, not our friend. Since the server is the one calculating the movement for the ships, by the time a position update reaches your computer, it's already outdated. That means that when you try to predict your movement from on board a boat, you're doomed to fail because you're working with a different starting position than the server is. It's kind of like taking two calculators and punching in different numbers, then adding one. Even though you added one to both, the result will never be the same because the starting numbers were different. Basically, you end up constantly mispredicting your position, which then triggers a correction, and sometimes that correction will put you inside the ship's collider because the ship position is outdated, and then the physics system loses its mind because colliders aren't allowed to be inside one another, but then that puts you in the wrong position again, so another correction is triggered immediately afterwards, and it causes a vicious cycle of violent jittering. So through the power of editing, you've been spared several more weeks of me questioning why I decided to build a multiplayer game or get into programming in the first place, but I'm pleased to announce that I have successfully made prediction smooth, even on boats. Since my prediction works on dry, non-moving land, I just made the boat also not move. I have this duplicate of the ship way under the water where no one will ever run into it, and when you step onto the actual, real, moving boat, both the client and the server start using this proxy to calculate your movement. You can think of it like being teleported onto the duplicate boat, except visually you still see yourself moving on the real one. Since the proxy doesn't move, there's no incorrect predictions to deal with, except when getting on and off of boats, because that's when the system has to change where and how it's calculating movement. The way it is now, the jitter is pretty noticeable when you jump off a boat, but since it's only for a moment, I think a bit of smoothing should be able to hide it quite well. Anyways, I'm super relieved that I finally got this working, but of course I'm building a multiplayer game, so I need to make sure to test this with more than one player connected at a time.